Today I am going to tell you the syllabus of physics for the first semester exam of class 10th ICSE, class 10th physics. The first chapter is force, turning force and circular motion. So the first topic which will come for the exam is translational and the original motion. This topic will come turning force of rigid body, point of action of force, line of action of force, and principle of transferability of force. These all topics will be there for the first semester exam. Then the moment of force and torque. What is moment of force, torque, and example based on hinge. Okay, and then clockwise and anti-clockwise movement. This topic is also there. Clockwise and anti-clockwise movements. What direction in clockwise direction and what is the movement of force in anti-clockwise direction. The unit of force, the relation 1 dan centimeter equal to how much Newton meter, the units of movement of force, and examples of movement of force. Then next topic came that couple. What is couple? And the example based on couple. See, first definition, first examples is the opening or closing of var tip. What is units of couple? The unit of couple is same as the moment of force, and the example. These examples are also there for the syllabus. And then the next topic came to equilibrium of bodies. What is equilibrium? What are kinds of equilibrium? There are two kinds of equilibrium: static and dynamic. Their definitions and examples. Dynamic. This topic also there. The principle of movement of force. What is principle of movement of force? And this diagram. And center of gravity. What is center of gravity? Then for regular bodies, for irregular bodies, for circular bodies, where is the center of gravity? And then uniform circular motion or circular motion. The difference between uniform circular linear motion and uniform circular motion. Centripetal force. What is centripetal force? What is example centripetal force and centrifugal force? These all topics are there. This is what is centripetal force, examples, and what is centrifugal force, examples, and difference between centripetal force and centrifugal force. From this chapter, nothing has been introduced. Full chapters will come for the exam, and only the some numerical problems will become based on formula, like power equal to like force equal to mg, and work equal to force into displacement, then torque equal to force into perpendicular distance. Only based on formula, simple questions will be asked. Not the complicated questions will not be asked. The second chapter, work, power, energy. Define work, factors determining work done of a body. These topics will be there. Then work equal to force into displacement. Then definition of work as a product of force or displacement in direction of body. Force, work is a scalar quantity. Special cases when under this formula, work equal to force into displacement cos theta. Then special cases when the displacement in direction of applied force, when the value of work done will be positive, and when the value of work done negative, and value of work done will be 0. See, special case is very important. Case first, case second, and this one case third. This with example you have to study. Then came to the units of work. These are units of work. Then bigger units of work. Then 1 joule equal to 10 to the power 7 erg. Rate of doing work is called power. What is the on which the power depends? Power is directly proportional to work, and power is inversely proportional to time. The formula of power on the basis of force into velocity. Then power can be defined as a product of force and velocity. What are the units of power? It's CGS system in a SI system, and what definition of difference between work and power. Energy, units of energy, calorie, kilocalorie. Then one hot hour equals 3.6 kilojoule, 1 kilowatt hour equals 3.6 megajoule. Then kinds of energy, power, energy. Then one power energy, 1 electron volt equal to 1.6 in 10 to the power minus 19 joule. Kinds of energy, mechanical energy, heat energy, light energy, sound energy, magnetic, electrical, chemical, nuclear. What is kinetic energy? Example, definition with formula. Forms of kinetic energy: translational, rotational, vibrational. What is mathematical expression of kinetic energy? Equal to 1 by 2 mv square. And the relation between kinetic energy and momentum is also the topic. Energy as work done is also here. Potential energy. Example, forms, mathematical expression, MGH, law of conservation of energy, diagram based question will be also asked. And the dissipation of energy is not included in the syllabus. This topic have been not included in the syllabus. This topic have been reduced, but one time you did it, the phenomena of transformation of useful energy from a useless form to a useless form is called a dissipation of energy. One time you can read, and it's very important. Examples of conservation of energy. Example of conservation of energy. And the simple numerical also are included in this chapter based on only on formula, like force equal to mg, work equal to force into displacement, power equal to work upon time, kinetic energy equal to 1 by 2 mv square, potential energy equal to mgh, and momentum equal to mass into velocity. Next chapter is the machine. What is machine? What are kinds of machine? Kinds of machine, functions of machine, general terms used for these all topics are there. Then what is the principle of machine? Input equal to output. What is mechanical advantage? Ideal mechanical advantage, axiomatic advantage. Then velocity ratio with formula. Efficiency of machine. Efficiency equal to output upon input, or MA upon VR. Relation between IMA and VR on a perfect. IMA equal to VR, and the lever topic has been reduced. This topic has been reduced fully. This topic will not come for the first semester exam. Okay, this topic has been reduced. This from here, lever fully has been reduced. Okay, this topic fully has been removed. Nothing will come for this chapter. This fully has been removed, and only the formula numerical problem based on that in efficiency, mechanical advantage. Write the equation. One diagram will be given. Write the equation for this. Then load into load arm, effort into effort arm. Okay, like this one question will be asked. Find velocity ratio, mechanical advantage, efficiency. Okay, but lever problem will not be asked. Next, the pulley, which will come for the first semester exam. What is pulley? Single fixed pulley. What is the mechanical advantage? What is efficiency? Velocity ratio. Then single movable pulley, velocity ratio, efficiency, mechanical advantage. Then the sheaf pulley systems or block or tag system of pulleys are also there. What is the velocity ratio, efficiency? Okay, then numericals is also important. Numericals will come from these chapters. Okay, you can solve one time numericals. Okay, then calorimetry has been fully reduced. This chapter calorimetry has been fully reduced. Nothing will come from this chapter. Fully has been reduced. Okay. Okay, then come to the refraction of light. In light, what is refraction? what is reflection, some definition of incident ray, point of incidence, direction of ray of light on which it depends. When the ray of light travels from rare to denser, it bends towards normal. When the ray of light travels from denser to rare, it bends away from normal. When law of reflection is Snell's law of reflection, the incident ray affected normal light same plane, the effective index formula. This topic has been reduced. This topic will not come. Mathematical expression for the verification of laws will not come. Okay, this topic has been fully reduced. Okay, and reflection and speed of light. What is the speed of light in vacuum? 3 into 10 to the power 8 meter per second. Then what is lateral displacement, on which the lateral displacement depends? Okay, the principle of reversibility of light. These all topics are there. Then the numerical problems is simple, only you can solve that. Real and apparent depth is also there in the syllabus with diagram. Real and apparent depth. Some effects of reflection is also there, full there. But the multiple images of this is not there. This has been reduced. Okay, this has been reduced. This topic is not there in the syllabus. This topic has been reduced. And numerical fully has been reduced. This numerical will not come for the syllabus. This numerical will not come for the syllabus. This numerical will not come for the syllabus. Then come to total internal reflection. Why total internal reflection? Total reflection, critical angle, conditions, reflection between effective index and critical angle, applications of total internal reflection, total reflecting prism, emission through 180, 90. Okay, then reflection and total internal reflection, reflection through prism. What is prism? Deviation of prism, on which the angle of deviation produced by the prism depends upon. Okay, and then this diagram, then the very important this one. This you don't have to say one time. You can this topic one time you can read, but this from this here important. Reflection to 90, 30, 60, and this also the syllabus reflection through 60 and 60. Then come to lens. What is lens? How many types of lens? Converging lens and diverging lens. Why we call this converging lens? Why we call diverging lens? How many types of lens are there in convex lens? How many types of lens are there in concave lens? Then convex action of convex lens. This full is there. Full page. This full page is there. This also full page is there. The full page, full. Geometric construction image in convex lens is this topic have been this topic very important for the exam. This topic will come from this many questions will be raised. Okay, so study well this chapter. These are topics also there. Sonic convergence of lens. This full chapter, this full page, this also full page. Almost this formula very important. And from this has been reduced fully. Power of lens and the simple microscope. This has been reduced. Okay, from this nothing will come. And from this the simple numericals will only be asked based on formula equal to 1 by f equal to 1 by v minus 1 by u. Okay. Then electromagnetic waves and spectrum, full page has been reduced. Only the general terms, what dispersion, what is spectrum, and what impure spectrum, pure spectrum, and this diagram will come for the syllabus. And this topic has been reduced. Only this and this what only will be there for the first semester exam. Okay. Then this full has been reduced. This full. What is invisible spectrum and the infrared spectrum is also there in the syllabus, and ultraviolet spectrum is also there in the syllabus. This properties and all one time you can read. Okay, this property one time you can read. And from this light as electromagnetic waves, only this box is there. This have been reduced. Fully. Why this box is important, and this has been reduced. Nothing will come from this. Nothing will come from this. Then come to the sound. What is reflection of sound? Experiment. Practical application of function of sound. An example, echo. What is an echo? What is persistence of availability of persistence of hearing? What is reverberation? Conditions for the formation of echoes. These all topics. Full page is there, and this also full page. Use of echoes. One time you can read. Use of echoes. One time you can read this one, and this also full is there, and the numerical is also there from this chapter. Okay, this much are only there for syllabus of the first semester exam. Thank you.